Hey everybody, we're going to continue the 2018 MCAS. This is session 2, so it's a calculator session, and the PDF is found in the video description. So if you want to try this first, which I'd recommend, download the PDF, try these problems out, and then you can watch these to go over the answers. All right, so we're going to start off with number 29. A physician recorded the resting heart rates of some of her patients. She also recorded the average number of hours each of those patients exercises daily. She'll make a graphical display of the data to help determine whether the two variables are associated. Which of the following displays should the physician make? And there's 4 options here. There's bar graph, scatter plot, circle graph, box whisker plot. So she's comparing the resting heart rates to that of their, number of hours they exercise. So she's trying to see if there's a relationship that exists between the amount of exercise they're getting daily and their resting heart rate. So you're looking for something that can compare two values and measure if there's some sort of relationship or correlation. So scatter plot, I think, would be the best one of the 4. Yeah, we go with that. Number 30. For all non-zero values of x, which of the following expressions has a value of 1? So the best way to do this is just kind of simplify each one. So 4 times negative 4 is negative 16, and x times x is x squared. Okay. 4 times 1 is 4. X times 4x is 4x squared. The 4's cancel, so this would be 1 over x squared. Here we have 4 times negative x, that's negative 4x. And x times 4 is 4x. So the x's and 4's cancel, we have negative 1. And then here we have 4x over 4x, and that would equal 1. So D is our answer. Number 30. Okay. An animal population doubles every month. The population begins with 20 animals. Which of the following expressions shows the animal population after 3 months? Okay. So our starting value is 20. Right? The growth factor is 2. It's doubling, right? And the time that goes by is 3. So this looks like the answer to me, because that'd be your starting value, that's the growth factor, and that's the amount of time. If we're not sure about that, we can't tell. We can actually test this out. So it doubles every month for 3 months. So our starting value is 20, right? It doubles, it becomes 40. So this is after 1 month. Then it doubles again, it becomes 80. That's after 2 months. And it doubles again, it becomes 160. After 3 months. That's our finished value. Now, if you weren't sure about which of these formulas it was, you could do this and then simplify all these and see which one's equal to 160. That's another way of doing that. So if you're not sure how to show a geometric sequence, which is what this is, you can actually cheese this problem by doing that. Okay. Right, number 32. The distance from the base of a flagpole to a point on the ground is 24 feet, as we see here. The flagpole has a height of 18 feet, as shown in the diagram below. What is x, the distance from the top to the bottom? So what kind of triangle is this? Well, it's a right triangle. And we're missing a side of a right triangle. We have 2 of them, so we can use Pythagorean Theorem to find it. A squared plus b squared equals c squared. We're going to just label this a and this b. It doesn't really matter which those are, as long as it's not the hypotenuse. Hypotenuse has to be c. So 18 squared plus 24 squared equals c squared. Let's go ahead and use our calculator here. So 18 squared is 324. 24 squared is 576. It's going to be 900. I'll find the square root of both sides, and that should give us 30. All right, so that's 30 feet. Let's see. Okay. Number 33. In a community college class, the interquartile range of students' ages is 20 years. Okay, the IQR is 20. The median age is 30. Which of the following box whisker plots could represent the distribution of the ages of students in class? All right, so let's first eliminate. There's the bell. Let's first eliminate those that do not have a median of 30. Median is going to be the Q2, or that line segment that's in the middle of the but it's in the box. So this is not 30, it's 35. That's out. This is 30, so that's a possibility. This is 20, so that's out. This is 30, so that's a possibility. So we're down to B and C. Okay, now we're told the interquartile range is 20. So interquartile range is Q3 minus Q1. It's the difference between the edges of the box, essentially. We're trying to figure out how wide the box is. So this is 35 minus, there's our Q3, so Q3 and Q1. So 35 minus 25 is 10. So IQR here is 10. That's not going to be it. Let's make sure this is 20. It is. 40 minus 20. That's 20. So with IQR of 20, so that means it has to be D. Okay, not too bad. Okay. A right square pyramid, and the dimensions are shown below. So we have the length of this edge here is 2.5 meters. The height is, vertical height is 4 meters. Which of the following is closest to the volume of a right square pyramid? So let's find our formula sheet. Use that. Hold on a second. Where are we? Pause this for a second while I find it. Okay, so the volume is what we're looking for. So if you look under volume here, volume of a right square pyramid is right here. So 1/3 s squared times h. Okay. Okay. Should always have that formula sheet handy. Get used to it. The digital version, though, is just a button you press on the screen. Okay, so V equals 1/3 s squared times h. The s is the length of the side here of this edge. That's going to be 2.5. So 1/3 2.5 times h, which is 4. You notice this is closest to, so we're going to end up rounding this. So let's do that. So 2.5 times 4. That's 10. So 1/3 of 10. Figure what that is. It's 10 divided by 3. It's 3 1/3. Oh, I totally screwed up. You know what I forgot? Totally forgot the squared symbol here, and that would have been bad. So good thing I caught that. Still feeling a little under the weather here. So let's do the exponent first. Let's do 2.5 times itself. Good thing I caught that. 2.5 squared. 6 1/4. All right, so 1/3 times 6 1/4 times 4. And 6 1/4 times 4 is going to be 25. 25 over 3, it should be close to 8. 25 divided by 3. Yep, 8 1/3. So roughly 8 1/3. So the closest one would be right here. Okay. All right, so we have the percentage of Beatrice, that's an interesting name, and Beatrice's income that she budgets each month for the different expenses is shown in the circle graph below. Other entertainment, utilities, food, and housing. So Beatrice budgets $900 for food each month. Based on the circle graph, what is the total amount she budgets for housing each month? So we need to find out what the amount that housing is, the actual amount. We know the percentage. We don't know how much total money she has. We're going to find that first. So we know food is 30% of her total budget, right? So we're going to say 30% as a decimal is going to be 3/10, so 0.3 times the total budget, which we're going to call, I guess, B for budget, equals $900. That would make sense, right? So we're going to solve for the budget by dividing both sides by our coefficient, which is 3/10 here. Oh. We're going to do that. I think it's 3,000, let's say. 900 divided by 3/10. Yep, 3,000. So our budget's 3K. Okay. And then we need to know what 45% of that is. So we're going to convert that to a decimal, and we're going to multiply that by 3,000. So it should be a little, well, let's see, it'd be a little less than 1,500, right? So 0.45 times 3,000, 1,350. which is the bottom option. There we go. All right, so I think we're going to stop there, because I think the next one's open response. It is. So that probably deserves its own video. All right, thanks for watching, guys.